Hello friends, myself Arnab Kundu. You are watching my channel Technical Arquin. This is the another video on Arduino using Tinkercad web application. And today's topic is that 4x4 keypad interfacing with Arduino UNO using Tinkercad web application. So go to the computer screen through Tinkercad web application. I will discuss today's topic step by step. So let's start. So friends, today I will discuss one of the topic on Arduino, and today's topic is that 4x4 keypad interfacing with Arduino UNO using Tinkercad web application. Okay, so a 4x4 keypad connects with the Arduino to determine which key is pressed by the user through the intersection of row and column by the switches between them, right? To connect the 4x4 keypad to Arduino, we need to interface 4 row pins in the keypad, which are R1, R2, R3, R4 respectively, with the Arduino digital pins 9, 8, 7, 6, and the 4 column pins, which are C1, C2, C3, C4 respectively, with Arduino digital pins 5, 4, 3, 2, right? So here 9, 8, 7, 6 and 5, 4, 3, 2, these digital pins I'm using in my sketch, right? So this is the keypad image where the 8 pins are there. First 4 pins for rows, that's why R1, R2, R3, R4 respectively, and after the rest of the 4 are for the columns from C1 to C4, right? And also this is a 4x4. Why? There is a 4 rows are there and 4 columns are there, right? Keypads are very important and it is used in many applications like telephones, calculator, television remotes, vending machines, combination locks, digital door locks and ATMs, right? Now, what is the 4x4 keypad module? A keypad module is a commonly used input device that consists of an array of buttons arranged in rows and columns, whatever I already shown, right? The most common ones are 4x4 where 16 keys are there, matrices, right? When interfaced with an Arduino, a keypad module allows users to input values which can be used for applications like security systems, calculators and user interfaces, right? So some of the functions I am using in my sketch to do the keypad module interfacing with Arduino UNO in Tinkercad web applications, like make key maps. This function is used to initialize the internal key map to be equal to the user defined key map, right? And also the object we are using here, the keypad is a class and some object name we have provided here, C keypad, and here we also use a constructor. This is a keypad, is a constructor, and send the make key map this function as argument. Also row pins, call pins, rows and calls. This variable also we are sending as argument. This defines an object C keypad of the class keypad and initializes it. Okay, so in that case we need a header file. The header file name is keypad.h, right? Means we need to include within our sketch, right? And also the get key, this function is also used in that way. Object name dot get key, so the object name is C keypad dot get key. This function is used to identify which key is pressed on the keypad. So this is the image of keypad module, right? So go to the computer screen. Through Tinkercad web application, I will design the circuit and also write the sketch. So let's dive in. So friends, I am already logged in with my Tinkercad web application account. So at first we click on create and then select circuits. Okay. So from there we at first select our Arduino UNO, this board. Okay. And also we type here keypad, this module. So we select this keypad, this module from there. So this is a 4x4. Why? 4 rows and 4 columns are there. So now the simple circuit is concerned. At first we connect all the rows from R1, R2, R3, R4 respectively 9, 8, 7, 6, these pins, digital pins, and rest of the 4 for the columns from 5, 4, 3, 2. Okay. So we just connect. At first we choose already the green wire for rows. So just connect from there. At first R1 just connect with this 9, this pin. Okay. R2, this row just connect with pin number 8, digital pin number 8. Okay. R3 just connect with digital pin number 7. Okay. R4 is the last row, just connect with digital pin number 6. Okay. Now we connect the columns. So we select the different color of wire for columns. So C1 just connect at first the digital pin number 5. Second column connect with digital pin number 4. Third column connect with digital pin number 3, and last column connect with digital pin number 2. The circuit is very simple. First 4 for rows, last 4 for column. Rows are connected with 9, 8, 7, 6, these digital pins, and columns are connected with 5, 4, 3, 2. Okay. So now we write the sketch. So go to code and just select from their text, click continue. Whatever written into there, just remove it. So at first we define the header file. We already told the header file is keypad.h, K is capital. So just write hash include within angle bracket, just write keypad.h, and we are defining lots of variables here. So at first we are defining const byte rows equal 4, and another variable const byte calls equal 4. Why? Because in our 4x4 keypad have 4 rows and 4 columns. That's why we are defining that. Now we take 2-dimensional character array. So just write char and just write hexa keys, and the dimension is 4, 4. So that's why rows and calls whose value is 4, 4, right? And we are defining some sets. Data sets means character sets we are defining. So first row contain 1, 2, 3a, second 4, 5, 6b, third 7, 8, 9c, and fourth asterisk 0 has t. So we are defining here as a character. So first is 1, 2, 3 and capital A. Close this brace. Second line we are defining second set, within single quote define 4, 5, 6 and within single quote define B. Brace close, comma, next character set. This start with 7, 8, 9 and capital C. Brace close, comma, and the last character set which start from asterisk, then it's the 0 and then it will be the hash, and the last one is your D. Okay, so we already define all the character set for 2-dimensional character array is concerned. Okay, now we define the to one-dimensional array. So just write here byte row pins, okay, and the dimension is rows, means 4, and we are defining the pin number whatever we already set within this circuit. So rows pins are 9876, so just write 9876, okay, and same way define for column. So byte call pins, and just write here the dimension calls, which is also 4, and same way we are defining the pin number for that, which is 5432, okay, brace close, semicolon. And now we are defining the object of the keypad class. So just write keypad, and the object name we are defining as C keypad, okay, and just write equal, and then just write keypad and send the lots of argument, and the first function is that make key map. So just write make key map and send the argument of this two-dimensional array, which is a character array. So just write hexa keys, parenthesis close, comma. Also send another argument row pins, also call pins, and also rows, comma, and last argument is calls. So these are all of the argument of this keypad constructor, okay. Now write the void set of this function, okay. So just write here void setup, which is only done one time, and there are only one statement, which is serial dot begin, and argument is 9600. We already know, because whatever the button we press from this 4x4 keypad, it should be shown within this serial monitor. That's why we need this statement. So single statement for void setup, and now we write the void loop, which continuously rotate, okay. So at first we define a character, so just write character variable is name, suppose key, and here we defining a built-in function which is get key, and it called by this object C keypad. So just write C keypad dot get key, okay. Now we check if key, then it will print serial dot print key pressed, put a colon, double quotient, parenthesis close, semicolon, and last we print the key serial dot print ln, and just send the argument key, this variable. Then if is closed, then void loop is closed. The simple code already right here, okay. Now we start simulation, okay. So there is no error, so just open the serial monitor, just press 1, yes, key pressed 1, press 2, yes, key press 2, yes, key press D, press hash, yes, hash, press 0, yes, press B, yes, press 8, yes, press 4, yes, press asterisk, yes, press 3, yes, press A, yes, press 6, yes, press 1, yes. So this is a very simple circuit, and through this circuit we can easily press anything from this keypad, and it should be shown in the serial monitor. I hope you have understood today's video. If you have some doubts for today's video is concerned, just write in the comment section. I will try to solve this problem. Those who are still not subscribed my channel, please subscribe it. Keep watching Technical Arcade for more videos. So today, up to this. Thank you and bye bye.